Howdy, PreCal. It is Miss Kosh. We are continuing our unit on conics, and so this one is on hyperbolas. So this looks a little funny, but basically what happens is if we take a cone, well, two cones, a cone inverted on another cone, and we slice it in such a way that it's perpendicular to the base, we get a little piece here and a little piece there. And so those pieces we call that a hyperbola. So a hyperbola is a set of all points where and everything can be described by slicing a cone, but also in terms of distance. Okay, so where a hyperbola is a set of all points where the difference of the distances from any point on the hyperbola to two fixed points called foci, that's the plural of a focus, is constant. Okay, so basically what happens is in our hyperbola, we'll have a point over here that's the focus. We can get, and then we have another point that's about over here that's the focus. What happens is this, if we have a point on our hyperbola, say this lovely little point right here, this distance here minus this distance here is the same amount no matter how I move this point along along the hyperbola. Okay, so if I took this whole thing and subtracted away that, I would get a certain amount that would be the same as if I took this and subtracted away that. I don't know if that made sense. But there used to be a cool little website that showed this pretty clearly. I'll see if I can go find it. It may or may not still be working, but okay. Hyperbolas are formed by slicing a double napped cone, okay, perpendicular to the base. Okay, and so these hyperbolas can either open up left and right or up and down, okay? And so they open up left and right when the x term is what's positive and the y term is what's negative. So if you remember, this equation looks very similar. It's hard to see it. It looks very similar to what we did for an ellipse, but an ellipse would have an addition sign between these. And in a hyperbola, it's a subtraction. Okay, so it'll open up and down when y is positive and x is negative, and it'll open left and right when x is positive and y is negative. Okay, let's zoom out a little. There we go. Okay, so the reference, when x is positive, it opens left and right. When y is positive, it opens up and down. The asymptotes, so here's how we find the slope. And what we're going to do is we're going to use the center. The center is still the point HK. It's always the point HK. But to find the equation of the line, find the equation of the asymptotes, we're going to say y minus the y component of the center is equal to our slope plus or minus b over a. Oh, okay. Times x minus h. So on this one, our slope is going to be rise over run. Well, here, it depends on how you define these things. It's the rise over run. So it's whatever corresponds with y that goes in the numerator and whatever corresponds with x that goes in the denominator. And then we're gonna end up writing this in point slope form. And then the foci is going to be c squared equals a squared plus b squared. So what happens is if you remember when we did the ellipse video, we said that a plus right here corresponds to a minus right here. Well, now we're looking at a minus here that corresponds to a plus here. Okay, let's jump in and do some examples. So here is hang on, I need my reading glasses. Okay, I'm so sorry. Our center is going to be HK, so our center is the x value. Now be careful that you don't just do first and then second. You want to make sure you're getting the x to go first and then the y. So like negative 3 positive 1. On this one right here, so if I said, oh, negative 3 positive 1, that would be wrong because I need my center is going to be the x component and then the y component. So it would be 1, negative 3. We'll do that one in a second though. Okay, horizontal or vertical. You know what? I want to think about how does it open. This one, it's going to open left and right. Let's just call that right. Let's just say it opens left and right. I don't quite know what they mean. What exactly is horizontal? Anyway, whatever. Okay. The a value here under x is going to be the square root of 16, which is 4. The b value would be 3. Okay, so what we'll do is we'll start along, we'll find the center, 1, 2, 3, -3, and +1. And then we're going to move this much in our x direction. We're going to go 4 units, 1, 2, 3, 4. We're going to go 1, 2, 3, 4. We're going to go 3 units in our y direction because that's what's under the y. 1, 2, 3. Hopefully I can count. 1, 2, 3. And then we will take those and turn them into a box. Okay, and so I'm going to do these little dotted lines to go, and so these become the midpoint of my little box. And then what we do next is we draw an asymptote through the corners. The diagonals become, we extend our diagonals, there we go, and they become asymptotes. Okay, so what is the slope of the asymptote? Well, we can do slope first. We went up. How much did we go in the y direction? We went up 1, 2, 3. We ran 4. So our slope is going to be plus or minus 3 over 4. So the equation of our asymptotes is going to be y minus the y value is equal to our slopes plus or minus. So this is actually 2 equations in one, and times x plus 3. And so if I wrote those in individually, they would give me these right here. My c value is comes from a squared plus b squared is, well, c squared is equal to a squared plus b squared. This is a 3, 4, 5 triangle. So 9 plus 16 is 25, square root of 25 is 5. The vertices are always, the graph will always pass through the vertices. So since this is opening left and right, it's going to kind of do something like this and something like this. It starts approaching those asymptotes. The vertices are here and here, so I see a +1, +1, 1, 1, and it's also the point, what would that be? They were 4, 8 apart, so -7, is that right? That was a -3, and we had to go 4 more. Yes, it is -7, +1. The foci are going to be 5 units from the center. So 1, 2, 3, 4, 5 puts it here, and then that's 1 more unit beyond that. So we're now, the foci would be at 2, 1, and -8, 1. It's 1 more unit beyond in this particular case. The transverse axis length. I don't know what they're talking about. I don't care. We don't need that. I didn't write these notes. I mean, maybe I should go look it up, but I don't know that I care. The domain is, we're going to go from -infinity to this point right here. So -infinity. This got us to, what was that, to -7. There were, oh, a hard bracket, my bad. That was wrong. Did you catch my mistake before I did? Union, and then we're going to go from here on, and so that has a hard bracket on +1 to infinity. The range, notice we're going up and down everywhere, so this is just -infinity to +infinity. Okay, let's look at the next one. So this one felt familiar with the 3. We already wrote down the center because I wanted to make a point that you got to keep the x with the x. So I would come over here, 1, -1, 2, 3, and then I would move in my x direction 5 units. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. I would move in my y direction 2 units, 1, 2, 1, 2. Was that 1? There it is. Okay, and I'm going to turn this into a box. And then I'm going to draw my asymptotes, go through the diagonals. Well, that wasn't a perfect line, but pretend I'm right. Okay, this one, since the y is positive, we're going to open up and down. So we're going to do something like this, approaching those asymptotes. Well, that doesn't look great, but okay. Here we go. The vertices are these points that it passes through. So this is +1, -1. Vertices, +1, -1, and +1, -1, 2, 3, 4, 5. And it was forward wide, right? So that does make sense. +1, -5. Okay, I skipped a lot of things. Horizontal or vertical, let's just tell it that it opens up and down. That makes more sense to me, and I'm grading your papers, so I will change things as I need to. The a value, well, we drew the box. We're fine. The c value is going to be, okay, so c squared is equal to a squared plus b squared. So I see 4 plus 25 is 29. So we're going to have a c value. C squared is 29, so c itself is the square root of 29, which is a little more than 5. So the foci will always be inside where it's opening. So we're going to come up 1, 2, 3, 4, 5. A little bit more is going to be here. 1, 2, 3. Okay, I lost count. 1, 2, 3, 4, 5. A little, so something like about there is our foci. So to write that equation, we had an x value of 1, and that didn't change because they're all on the same little x equals 1. And I started at, what was my center? -3. And then I added and subtracted the square root of 29. And that will work for the foci. The asymptotes, I had a rise of 2 and a run of 5. So my asymptotes are going to be y plus 3 equals plus or minus 2/5 times x minus 1. I'm using this point to come up with those equations. Don't care. Domain is going to be all reals. My range is going to go from -infinity. How high was this? This was the point -5. Or well, the y value -5. So it's going to go from -infinity to -5 hard bracket. Pick it up again. This was -1 to infinity. And there are those first two. Let's look at the next one. Write the standard form of the equation of the hyperbola with foci, that and that, and vertices, that and that. Okay, so let's see. I'm going to sketch this out. A foci -1, +2 is somewhere here. 5, 2. So they have a total from -1 to 5. This is a total distance of 6, which means that my c value is going to be half that. It's going to be 3. And then vertices. My vertices should be on there. 0. Okay, they are 0, 2, and 4, 2. I was thinking. Wait. Anyway, I don't know what I was thinking. And so this 0, 2 to 4, 2. This distance through here is 4, which means that my a value will be equal to half of that will be 2. Okay, so c squared is equal to a squared plus b squared. So 9 is equal to 4 plus, well, b squared will equal 5. Oh, I'm sorry, you couldn't see what I was doing. I apologize. Okay, so now this is going to open. So here's my vertice. It's opening this way, and the foci is inside. So this means that the x comes first. So it's x. What's the center? Well, the center halfway between 0 and 4 is 2. So x minus 2 squared over something minus the y value was also, the y value for all of these was 2. So y minus 2 squared over, okay, how much did I move in the x direction? I moved 2 units, so 2 squared is 4. We found this b value to be b squared to be 5 is equal to 1. And that's the standard form. Okay. How are we doing? Oh, we can go some more. Okay, so write the equation of the hyperbola in standard form and find the asymptotes. So on this one, we need to make this equal to a 1. So we're going to divide everybody by 16. And this gives me x squared over 4 minus y squared over 16 is equal to 1. Find the asymptotes. Oh, okay. Well, notice the center is 0, 0. And then, so if I were to graph this, I'm at 0, 0. And how much did I move in the y direction? I'd go 4 units up. I'd go up 4 and over 2. So this is going to be, I went up 4 over 2. So my rise over run is going to be 2 divided by 4. I lied. 4 divided by 2 is 2. So we have a slope of plus or minus 2. So that one's going to be positive. That one's going to be negative. And so then I have y minus my y1 is 0. Y equals plus or minus 2 times x. And there we're passing through 0, 0. Okay. Write the equation of the hyperbola in standard form and find the asymptotes. All right. So on this one, I have to complete the square. I might need more space. Okay, so I'm going to factor out a 25 from the x squared term, and I have a minus 150. If I have $1.50, I have 6 quarters. So this becomes x squared minus 6x plus a box. Now I'm going to factor, so I have used this term and this term. And now I'm going to factor out a negative 16. That gives me a y squared. And then, oh, that's nice, a positive 2y plus a triangle equals 191 plus, if I have to add 25 box, and I have to subtract 16 triangle. I have to do the same thing on both sides. And I get 25 times this half of negative 6 is negative 3 squared. 3 squared puts a 9 in my box, a 9 in my box. Minus 16 times half of 2 is 1. 1 squared puts a 1 in my triangle. Okay, and I don't really feel like thinking of doing arithmetic in front of you. So I see a 191 plus, oh, that's, if I have 9 quarters, that's 225, but I'm just going to make sure that times 9 minus 16. Okay, and that's 400, which makes sense actually. So then I'm going to come along and divide everybody by 400. It would be really convenient if 16 times 25 was 400. 400 divided by 16, 25. Oh, hallelujah. Okay, so this becomes an x minus 3 squared over 16 minus y plus 1 squared over 25 equals 1. And so the equation of, write the equation of the hyperbola standard form. That is what we just did. Find the asymptotes. Okay, so our center, can you see what I'm doing? Not so well. The center is at 3, negative 1. And our slope, we're going to go up 5 and over 4. Our slopes are going to be plus or minus 5 over 4. And so now I have y minus y1 equals m times x minus x1. Y plus 1 equals plus or minus 5/4 over x minus 3. And that's it. So here was one part of the answer, if I can circle that properly. And here's the other part. Determine the conic section based on the equations graph provided. Oh, okay. Well, this is an ellipse. This is a hyperbola. Oh, I'm sorry, you couldn't see it. This is a circle. This is a parabola that we haven't studied yet, but we will. So the parabola is the only one that only has one thing squared. So if I see there's two things squared, two different variables are squared, two variables are squared. So I don't see none of those equations are a parabola, but that was a picture of a parabola. Okay, so then if I see a subtraction, like this. So if I see an x squared and a y squared with a subtraction between them, that's a hyperbola. Okay, here's another one. Here's the squared, here's the squared. So this is also a hyperbola. Okay, here's a square, and there's subtraction between them. That's also hyperbola. Okay, and now we can look at the other ones. Everything else is a plus. If they have the same, if it's, well, x squared and y squared don't have, if they have different coefficients like this over here, then that would be an ellipse. It needs an E. I was moving on. I can't spell. Okay, this one also has different ellipse. This is the same, so this is a circle. And this is the same, so this is a circle. If you don't believe me, you could complete the square on all of these, and we will practice some more of that. But in the meantime, like, subscribe, comment if you have any thoughts, suggestions, or questions. And the only way to learn math is to do what? Is to practice. So go practice.